Good morning to all. This is Dr. Padma, Assistant Professor, Department of Physics, Institute of Aeronautical Engineering. Today's topic is phototransistor. So, today we will discuss about these topics. Introduction about the phototransistors, structure and working principle, modes of operation, circuit configuration, types of phototransistors, characteristics and advantages of phototransistors, and applications of phototransistor. Introduction. So, in a modern electrical circuit, different kinds of sensors are used. So, the photo sensor is one of these sensors used for sensing and keeping monitoring light intensity. So, in a modern electrical circuit, different kinds of sensors are used. So, the photo sensor is one of these sensors used for sensing and keeping monitoring light intensity. So, although it functions similarly to the photodiode as a type of photosensor. So, a phototransistor has an application factor. So phototransistor is an amplification factor. So, using the intensity of the light, it increases the current between the terminal. Here we are using the intensity of light which increases the current between the terminals. So, in modern electrical circuits, different kinds of sensors are used. So, photosensor is one of the sensors used for sensing and keeping the monitoring light intensity. So, although it functions similar to the photodiode, so all the functions are similar to photodiode as a type of photosensor. So, a phototransistor has an amplification factor. So, using the intensity of the light which increases the current between the terminals. So, phototransistors are the semiconductor devices. Those are widely used for the light detection and amplification. So, phototransistors are mainly used for the light detection and amplification. So, they are essentially transistors with light sensitive region, allowing them to convert light signals into electrical signals. So, these are convert the light signals into electrical signals. So, phototransistors are the semiconductor devices. Those are used for the light detection and amplification purpose. So, these are essentially transistors with a light sensitive region, allowing them to convert the light signals into electrical signals. So, phototransistors offer higher sensitivity and gain compared to the photodiodes. So, when we are comparing with the photodiodes, phototransistors offer higher sensitivity and gain compared to the photodiodes. So, these are suitable for the applications where the weak light signals need to be detected and amplified. So, the photodiodes are used for the identification of the weak light signals and amplification purposes. So, phototransistors offer higher sensitivity and gain compared to the photodiodes. So, these are suitable for the applications with weak light signals need to be detected and amplified. Phototransistors was invented in 1950 at Bell Laboratories by Dr. John Northrop Shive. So, it was operated by light rather than the electrical current. So, in phototransistors, we are using the light rather than the electrical current. Structure and working principle of the phototransistors. So, a phototransistor is a light controlled switch that switches a circuit and amplifies the current when exposed to light. When the phototransistor is exposed to light, so the circuit and amplifies the current which is exposed to the light. So, a phototransistor is a light controlled switch that switches a circuit and amplifies the current when the phototransistor is exposed to the light. So, the phototransistors are typically constructed using three semiconductor layers. Those are emitter, base and collector. Already we know that emitter, base and collector. So, by using these three semiconductor layers, we can construct the phototransistors. So, the base region is often made with wider and less heavily doped compared to the conventional transistors to enhance the light absorption. So, while fabricating the phototransistors, the base region is made with the wider and less which are heavily doped compared to the conventional transistors. So, that enhances the light absorption. When exposed to light, a phototransistor activates a circuit switch and increases the current. When the phototransistor is exposed to light, then the phototransistor activates a circuit switch and which increases the current. So, a light sensitive base at the bottom of the 3-layer semiconductor device is visible. So, the current between the emitter and the collector amplified proportional to the light intensity when it strikes the base, increasing the current provided by a base current. So, when the phototransistor is exposed to light, which activates the circuit switch and which increases the current. So, a light sensitive base at the bottom of the 3-layer semiconductor device is visible. So, the current between the emitter and the collector, the current between the emitter and the current between the emitter and the current which is amplified proportional to the light intensity when it strikes the base. So, when the light strikes the base, the current between the emitter and the collector is amplified and which is proportional to the light intensity when it strikes the base, which increases the current provided the base current. They are employed for detecting fast moving minute light pulses. It is similar to BJT, bipolar junction transistor, except for those exposed base instead of a terminal. So this is the symbol for the phototransistor. The first one shows the NPN phototransistor, second one is the PNP transistor, and third one is the field effect transistor phototransistor, which is called as the FET transistor. These are the symbols of the phototransistors. So they are employed for detecting the fast moving minute light pulses, which is similar to BJT except for the exposed base instead of the terminal. Here we are exposing the base with the light. These are the symbols for the phototransistors. So this is the phototransistor schematic diagram here, which shows the N-type layer is the collector, P-type region is the base. So here this is the emitter metallic contact. So this is the structure of the phototransistor. Here we are using the N-type region or N-type material as the substrate. Here it is the collector. This is the metallic contact. This is the N plus region. So N plus region is acting as the emitter. Here the light is incident on the phototransistor. This is the schematic diagram of the phototransistor. The working principle of the phototransistor is similar to that of the regular transistors. So the working principle is the same or similar to the regular transistor. When the light strikes the base region, it generates the electron hole pair. For example, this is the base. When the light is incident on this base region, here the electron hole pairs are generated. So once the light is incident on the base region, when the light strikes the base region, which generates the electron hole pairs. So the photon transfer their energy to the valence electron in the material, causing them to break free and create a mobile charge carriers. So once the light is incident on the base region, here the electron hole pairs are generated. So the photon transfers their energy to the valence electron. So by absorbing the energy for the valence electron, so those are taking a transition from valence band to conduction band. If the base emitter junction is forward biased, so if you are connected with the forward biased, then the electrons from the base emitter current flow into the base regions. So base emitter, so if the base emitter junction which is forward biased, then the electrons from the base emitter current flows into the base region. So the presence of the light increases the number of free carriers in the base region, leading to an increase in the base current. So if the base emitter junction is forward biased, the electrons from the base emitter current flow into the base region. So the presence of the light increases the number of the free carriers in the base region, which leading to an increase in the base current. So therefore the phototransistor is 100 times more sensitive than the photodiodes. When compared with the photodiode, the phototransistor is 100 times more sensitive compared to the photodiodes. So if the base emitter junction is forward biased, then the electrons from the base current flow into the base region. So the presence of the light increases the number of free carriers in the base region, which lead to increase in the base current. Therefore, the phototransistor is 100 times more sensitive than the photodiode. So the base current is generated on the principle of the photovoltaic effect. So here photovoltaic effect means the light signal or optical signal is converted to the electrical signal. So the base current is generated on the principle of the photovoltaic effect. So here the base current means once the light is incident on the base, it generates the current. That means the optical or light signal is converted to electrical signals. The base current is generated on the principle of the photovoltaic effect. So the amplified base current controls the flow of current from the collector to the emitter, resulting in the amplified output current. So the amplified base current controls the current flow from the collector to the emitter, the current flow is controls from the collector to the emitter, which results in the amplified current. So the collector current is proportional to the intensity of the incident light. So here the collector current is proportional to the incident light. So which allowing the phototransistor to detect and amplifies the light signal. So the amplified base current controls the flow of current from the collector to the emitter, which resulting in the amplified current. So the collector current is proportional to the intensity of the incident light, allowing the phototransistor to detect and amplifies the light signal. So in NPN transistors, the collector is maintained at the greater voltage with respect to the emitter during the biasing. So in NPN phototransistor, if you take the NPN phototransistor, the collector is maintained at the greater voltage with respect to the emitter during the biasing. So whereas PNP transistor. So in PNP phototransistors, the collector current is maintained at the lower voltage to the emitter. Furthermore, the collector to the base junction is the reverse biased. So if you take the NPN phototransistors, the collector is maintained at the greater voltage with respect to the emitter during the biasing condition. Whereas in PNP phototransistors, the collector is maintained at the lower voltage. So in NPN transistor, the collector is maintained at the greater voltage. So whereas in PNP transistors, the collector is maintained at the lower voltage to the terminal. Furthermore, the collector to the base junction is the reverse bias. So in the case of three lead phototransistors, the base terminal must be left unconnected or open, otherwise it will operate as the normal phototransistors. So a small reverse saturation current or leakage current is known as the dark current. So dark current means a small reverse leakage current or a small reverse saturation current, which is known as the dark current, exists in the absence of the light and is directly proportional to the temperature, just like in the photodiodes. So same, the dark current is exist in the photodiodes. So similar to the photodiodes, a small reverse saturation current or leakage current, which is known as the dark current. The dark current exists in the absence of the light, so which is directly proportional to the temperature, which is similar to the photodiodes. So the photovoltaic effect creates a base current when a light strikes the phototransistor, focusing the light onto the collector base junction. So the base current is amplified hundreds of times compared to the photodiode. So modes of operations. So the phototransistor is like the BJT, can function in either linear or active and switch mode. These are the modes of the operation. So the phototransistor, so which is similar to the BJT, the phototransistor can function in the linear or active and switch mode. So linear or active active mode. So the output current is directly proportional to the intensity of the incident light while operating in the linear mode. So linear mode means the output current is directly proportional to the intensity of the incident current. So the current output is directly proportional to the incident light. So in practical term, the response takes the form of the curve and is not a very linear. So in practical term, if you think practical, the response takes the form of a curve and which is not very linear. As a result, the correct term for this mode is the active mode. So that's why it is called as the active mode. So this mode is used for the amplification factor. So the linear or active mode is used for the amplification factor. So the gain of the transistor determines how much the generated base current is amplified. So the gain of the transistor determines how the generated base current is amplified. Switch mode. So in switch mode operation, the phototransistor operates in one of the two states, either on or off. Switch mode means on or off. So in switch mode operation, the phototransistor operates one of two states. Those are called off or on, just like a switch. Therefore, the name is switch mode. So due to the non-linear response of the phototransistor to the light, this mode is typically used. So the device is said to be an off state when there is no base current and no light. So off mode means there is no base current and no light. So the output current increases as the light intensity increases. If we increase the light intensity, the output current also increases. So there comes a point when the device is saturated and the increase in the light intensity has no effect on the output current. So here when the device is saturated, once the device is saturated and the increase in the light, if we increase the light intensity also, there is no effect in the output current. So it is said to be that the device is in the on state. Just like a digital switch, it operates in the two levels. So if you take digital switch also, here two levels are there, on and off. So on mode means if the device is saturated means there is no further increase in the current. So that mode is known as the on state. So due to the non-linear nature of the active region, this mode is used for the decoding, sending, object detection and signal conversion. So due to the non-linear, so there is no linearity, non-linear nature of the active region, this mode is used for the decoding, sending, object detection and signal conversion purposes. So circuit configuration. So it can be used in either common emitter or common collector configuration. So first one is the common emitter. This is figure 4 is the common emitter configuration. So in this configuration as shown in the figure, the collector is connected to the voltage source through a load resistor RC. Here RC is the load resistor. So in this configuration, the collector is connected to the voltage source through the load resistor RC and the output is obtained from the collector. So the output is obtained from the collector. Here this is the output. So with the detection of the light, the output voltage switches from the high to low state. So it is a frequently used configuration that acts as an amplifier. So in this configuration, the collector is connected to the voltage source through the load resistor RC and the output is obtained from the collector. With the detection of the light, the voltage switches from high to low state. It is frequently used configuration that is used for the amplifier. So common collector or emitter follower. Common collector is also known as the emitter follower. So this is the common collector. So in this configuration as shown in the diagram, the emitter is connected to the ground via load resistor. So here the emitter, this is the emitter. Emitter is connected to the ground via the load resistor RE and the output is obtained from the emitter. So in the previous case, the collector is connected to the ground. Now in this case, the emitter is connected to the ground. Then the output is obtained from the emitter. So with the detection of the light, the output voltage increases from low to high. Types of phototransistors. There are two main types of the phototransistors. First one is the NPN phototransistor. In NPN phototransistor, the base region is the P-type and the emitter and collector regions are the N-type. So the base region is the P-type and the emitter and the collector are the N-type materials. So in NPN transistor, so P is the base region, N and N is the emitter and collector regions. Those are prepared with the N-type material. So the light absorption occurs in the base region and generated the carriers contributes the base current which controls the collector current. So once the light is incident on the base region which generates the electron hole pairs and which increases the base current which controls the collector current. So in PNP phototransistors, the base region is the N-type. So here PNP, here the N is the base region. So the emitter and the collector are made with the P-type materials. So the operation and light absorption principle are similar to NPN phototransistor, but the carrier types are the reverse. Here the polarity can be changed compared to the NPN transistor. So in PNP means the base region is made with the N-type material and the base and emitter and collector regions are fabricated with the P-type materials. So FET phototransistor, this is the third type of transistor. So a field effect transistor, FET phototransistor is one that has the light sensitive channel but there is no junction. Either N channel or P channel can be used. Source and drains are the names of the two terminals. From the construction standpoint, drain and source are the interchangeable. So either N channel or P channel can be used to fabricate the FET phototransistor. Here the source and drains are the names of its two terminals. From a construction standpoint of view, drain and source are the interchangeable. So with respect to the source, the drain is positive. The drain current is controlled by the incident light. Because of its quick switching, it can be used in the high frequency application. So here the switching action is speed that can be used in the high frequency application. However, it allows the low current and gain. Performance parameters. There are certain parameters that define the performance of the phototransistor. These parameters must be kept in the mind when choosing the phototransistor to provide the cost-effective performance. Collector current IC. So the collector current is the maximum allowed load current. If the load current is exceeded, the phototransistor could experience the permanent damage. So the collector current is the maximum allowed load current. If the load current is exceeded, then the phototransistor could experience the permanent damage. So the base current represents the current produced by the incident light. It depends on the size of the base region. So the capacitance which affect the switching speed rises the area of the base region which increases. Then dark current ID. It is the leakage current between the collector and emitter when there is no light. So if there is no light is incident on the base, so the leakage current between the collector and emitter is known as the dark current. It is very small, that is in the terms of milliamperes. So ideally it meant to conduct no current. So but due to temperature it never shut off completely. Dark current is inversely affect the performance. So dark current is depends on the temperature. VCE breakdown voltage. It is the maximum voltage applied between the collector and emitter. If the applied voltage exceeds the breakdown voltage, the device is permanently damaged. So the maximum voltage applied between the collector and the current, that is known as the breakdown voltage. If the applied voltage exceeds the breakdown voltage, the device is permanently damaged. VEC breakdown voltage. It is the maximum allowed voltage applied between the emitter and the collector. It is relatively very lower than the VCE, common emitter voltage. So wavelength. So different photoconductive materials show different responses to a spectrum of wavelength. So that is depending upon the photoconductive material. So they show high sensitivity and conversion efficiency at narrow range of wavelengths. Therefore, the wavelength of the incident light is very important to have the high energy conversions. So the different photoconductive material shows the different responses to a spectrum of wavelengths. They show high sensitivity and conversion efficiency at a narrow range of wavelengths. So therefore the wavelength of the incident light is also very important to have the higher energy conversions. So linearity. Linearity means how linearly the output current varies with the change in the light intensity. So the incident light intensity changes. How the current is changes with the light intensity. That is known as the linearity. So linear response is precise and error free. Therefore it is necessary to know the linearity of the devices. Characteristics and advantages. Collector characteristics of the phototransistors. So the relationship between the collector to emitter voltage VCE and the collector current VCE and IC at different levels of light intensity is shown in the following graph. So this is the graph, the collector characteristics of the phototransistors. So the last one is shown as the dark current. So on x-axis we are taking the voltage and y-axis we are taking the collector current. So the voltage across the collector and emitter is shown on the x-axis while the collector current is shown in the y-axis. So on x-axis we are taking the voltage, on y-axis we are taking the current. So this is the graph between the voltage and the current. Collector characteristics of the phototransistor. Its characteristic curve is similar to the BJT with the differences that the gain is controlled by the intensity of the light. Here the gain is controlled by the incident intensity of the light. With increasing the light intensity, the collector current increases. There is a small leakage current or dark current. So when there is no light. So this is the spectral response of the phototransistor. So figure 7 shows the spectral response of the phototransistor. On x-axis we are taking the wavelength in nanometers. On y-axis we are taking the responses. So a small range of wavelength is where phototransistor work at their best as they are made of a photoconductive material that does not respond to all wavelengths. So the graph illustrates how the phototransistor spectral response related to its percentage response in terms of the wavelength. So here the graph between the response, percentage of response and the wavelength. So advantages, higher sensitivity. So the phototransistor offer higher sensitivity compared to the photodiodes. So it is 100 times more sensitive than the photodiodes. So the amplification provided by the transistor configuration allows for the detection of the weaker light signal, that is the higher sensitivity. Amplification. Phototransistor can amplify the weak current generated by the light signals, making them suitable for the application that require in the signal amplification. Gain. Phototransistor exhibit gain, which is the ratio of the output current to the input current. The gain can be controlled by adjusting the biasing conditions of the phototransistor. Response time. Phototransistors have relatively fast response time, enabling them to detect respond to change in the light intensity quickly. So, configurability. The phototransistors can be used in the various configurations such as common emitter, common base, common collector, allowing for the flexibility in the circuit design. Then applications of the phototransistor. Phototransistors find the applications in the wide range of the fields including optical communication systems. So the phototransistors are used as receivers in the fiber optic communication systems. So the phototransistors are widely used in the fiber optic communication systems. Those are used as the receivers to convert the optical signals into electrical signals for further processing of the optical fiber communication. So light sensing and detection. Phototransistors are utilized in light sensing applications such as light barriers, optical switches, light meters and ambient light detectors. So imaging devices. Phototransistors can be used in the imaging devices such as scanners, barcode readers for light detection and image formation. Industrial automation. Phototransistors are employed in the industrial automation for tasks such as object detection, position sensing and assembly line monitoring. These are the references used for the semiconductor devices. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.